Today in this session, we are going to discuss about the multiplication of two unsigned numbers. And then we are going to proceed with the computer hardware to perform the multiplication of two unsigned numbers. So to have a better understanding on this multiplication of unsigned numbers, we have been provided with the real-time scenario here. We need to multiply two numbers, and then the corresponding flowchart has been provided here. So first of all, before having a discussion on this unsigned numbers, we have to be clear with what is meant by an unsigned number. Unsigned number in the sense any pair number without positive sign or negative sign, without a plus symbol or negative sign, minus. Let us assume. So here, if we are performing multiplication means we have to have two numbers. One is called as multiplicand, another one is called as multiplier. So let us assume I am going to multiply two unsigned numbers. Let us assume I am taking 7 as one number multiplied by 3 as another. So these are the two unsigned numbers we are having. So 7 as one number and 3 as another number. Both the numbers are not having any positive or negative symbol, so we consider this as a unsigned number. And in these two numbers, we can tell the first number as the multiplicand. So I am taking the multiplicand value in the B register. I mean multiplicand 7 value in the B register. And then the second number is called as multiplier, and this multiplier value is to be stored in the Q register. So here I'm taking two registers. One register is named as B, and in that B register I'm going to store multiplicand value. So that's why I'm storing 7 here. And the second register is Q register. That's called as used to store the multiplier. That's why I'm storing 3 here. So coming to the flowchart and starting the process. So as a first thing, I have to initialize certain registers. What are the registers do we need for performing this multiplication of unsigned numbers? One is C register. So here we can able to see the C register. C register stands for carry register. And then A register. A register stands for accumulator register. And then as I mentioned, here we are going to use multiplicand register B. Actually, here it has mentioned as M. We can use M or we can use the notation as B, whatever it may be. So the multiplicand has been stored in the B register and the multiplier has been stored in the Q register. And then coming to the count, I will be explaining it after discussing about this multiplicand and multiplier. So first, mention the binary representation of this 7. 7 can be represented in 4 bits. So we can mention it as 0 followed by 1, 1, 1. So this is the representation for the 7. That is 0 to 1. And coming to the multiplier, in multiplier we are having the value as 3. So 3 can be represented in 4 bits. So we can represent as 0, 0, 1, 1. So as a first step, I have mentioned the binary representation of two unsigned numbers. We can take any numbers. So for those numbers, I am mentioning the binary representation. I repeat, the multiplicand value stored in B register and multiplier value stored in the Q register. So here we have to perform the Q's complement. I will be mentioning why and what is the need for performing the Q's complement. So right now I'm not mentioning and are not going to take any Q's complement right now. When we are doing the process, we can understand why we need the Q's complement of B value. So coming to the first thing, I mean C register has been initiated with the 0. So here they are mentioned as 0. And then A register, I mean accumulator register is to be stored with the default value of 0. So in the C register, look at this first one. C register has been given with the initiated with 0 and accumulator register has been initiated with the 0 value. And in the Q register, we have stored the multiplier value. What is the value for multiplier? 0, 0, 1, 1. So mention as 0, 0, 1, 1. So I repeat, this is the first process. This is the initial process. And in initial process, we are having carry register equal to 0, accumulator equal to 0, and Q register equal to multiplier. Now coming to the count value, that is how many times the corresponding loop has to be performed. So look at this loop. So how many times the corresponding loop has to be performed? I'll be explaining what the loop is going to work. So it is nothing but the number of bits in the Q register. I mean number of bits in the multiplier Q register. So what about the number of bits? Sorry, number of bits is 4 bits. So we can tell the count value should be equal to 4. So which means 4 times the loop will be executed. So coming to the illustration. So now I had initiated the value of carry register with 0, accumulator value with 0, and the multiplicand value stored in B register, and the multiplier value stored in the Q register. Count has been decided as number of bits in Q register, so it is equal to 4 bits. Clear? So coming to the first step, what is the first step here? Here we have to check what is the Q naught value. Among these 4 bits, which is the Q naught value? This least significant bit is called as Q naught value. So this is Q naught, this is Q1, this is Q2, this is Q3. So we can tell the least significant bit is the Q naught value. So we have to check whether Q naught is equal to 1. Yes, here the Q naught is equal to 1. So if the Q naught is equal to 1, what we have to perform here? Q naught is equal, here. A is equal to A plus B has to be performed. A is equal to A plus B, which means accumulator value plus this B register value, addition has to be performed, and the result has to be once again stored in the A register. So here we are having 0, 0, 0, 0. So let me make a value here. That is, here in A register, we are having 0, 0, 0, and 0, and plus B. Where what is B? B is 0, 1, 1. So 0, 1, 1. So on adding these two numbers, we'll be getting 1, 1, 1, 0. So on adding A plus B, why we are performing A plus B? Because Q naught is equal to 1. So here Q naught is equal to 1. So I'm performing A plus B. So A plus B value, I'm getting 0, 1, 1. So here I'm mentioning it as, I'm here mentioning it as 0, 1, 1, 1. And during this addition process, I have not obtained any carry value. So here also I'm making the same value. 0 is here, so I'm making the same value 0, and the same Q value has been stored here, 0, 0, 1, 1. So what we have done here, A, that is A, is stored with A plus B. I have performed A plus B, and the result has been stored in the same A register. So this is the first step, and after this one, what we are doing here, shifting the C register, shifting the A register, shifting the Q register. In what way we have to shift? We have to shift in the right-hand side. So after performing this addition process, we have to shift in the right-hand side process. So we are moving this one, that is, this 0 has been moved here. This 0 has been moved here, 0, and this 0 has been moved here, 0, and 1, 1, 1, and here the 1. This 1 has been moved here, and here this 0, or this 0 has been moved here, 0, 0, 1, and this 1 will be discarded. So what we are performing here? We are performing right shift here. So these two steps will be coming under the step number 1. First count has been over. Clear? That is, first count has been over. So I repeat the process. Since Q naught is equal to 1, I had performed A equal to A plus B. After that, I have performed the A right shifting process. So now this particular position is 0. So here, if the position is 0 means I am making it with 0 value. If the position is empty means I am making it with 0 value. So now, once again, we are going to, the count is not completed since only one count is over. I need to perform for 4 count. I have to go in for once again checking for Q naught value. What is the Q naught value here in the previous step? Q naught value is 1. So if Q naught value is 1 means once again I have to perform A equal to A plus B. So which means A equal to A plus B in the sense A equal to A plus B means, so once again, this 0, 0, 1, 1. So if we take 0, 0, 1, 1 plus, what is B value here? B value is 0, 1, 1. So 0, 1, 1 has to be taken. So 0, 1, 1, 1. 0, 1, 1 has been taken. Add together 1 plus 1 is 2. So 0 with carry. 1 plus 1 plus 1 is 3. So 1 with carry. 1 plus 1 is 2. So 0 with carry. And here it's 1. So on adding A plus B, we are getting 1, 0, 1, 0 without any carry. So in case carry extra generator. So there is no carry here. So I'm here mentioning it as no carry is generated, and then 1, 0, 1, 0 has been made. And here the same value has been brought down. So 1, 0, 0, 1. So sorry, 1, 0, 0, 1. So the same value, I mean the same previous value has been brought down here. Is it clear? So now after performing this one, I have to perform the right shifting. So after adding this one, I have to perform the right shifting value. So this 0 will be given here, 0, and this 1 will be given here, 1. So this 0 will be given here, 0, and this 1 will be given here, 1, and this 0 will be given here, 1, sorry, 0, and here 1, 0, 0, 1, 0, 0, and this 1 will be discarded. So we had completed the second process also. And here the position, carry position is empty, so I'm making it as 0. So once again, I had performed right shifting A plus B and then right shifting process. So now count number 2 is also over. So here, as I mentioned earlier, the totally we have to perform 4 number of bounds. So once again, I'm going and checking what is the value for Q naught here. So Q naught is equal to 0. If Q naught is equal to not 1, Q naught is not equal to 1, it is 0. So just I'm doing the right shifting alone. I'm not going to perform any A equal to A plus B. So just I'm going to perform a right shifting of the previous value. So this 0 will be given here, and this 0 will be given here, and this 1 will be given here, this 0 will be given here, and this 1 will be given to 1 here, and this 0 will be given here, this 1 will be given here, sorry, and this 0 will be given here, and this 0 will be discarded. So we had completed the third cycle, but one thing is, this carry flag remains empty. This carry flag still remains empty. So as I mentioned, if the carry flag is empty means we have to mention it as 0. So here I had performed only the right shifting process, and that's all the cycle number 3. So once again, check the count of the cycle. So the total count of cycle is 4. We have completed only 3 cycles. So moving to the 4th one, that is the final cycle. So now, once again, check for the Q naught value. This is the Q naught value. Q naught value is equal to 0. So if Q naught value is equal to 0 means, I mean, if it is not equal to 1 means, which means Q naught is equal to 0. If it is 0 means we have to perform only the right shifting process. So we have to perform only right shifting process of the previous one. So this 0 will be given here, and this 0 will be given here, and this 0 will be given here, and this 1 will be given here, and this 0 will be given here. Sorry, 0, and then 1, 0, 1, and this 0 will be discarded. So we had completed the 4th cycle also. So since now check whether the count is 0. Yes, count is equal to 0 because we had completed all 4 cycles. And here, as I mentioned, carry flag is empty. So if it is empty means 0. So now we had completed all the 4 cycles. Then what about the result? So what are the numbers we had considered here? We had considered 7 into 3. Actually, 7 into 3, we have to obtain 21. What value should be there? 7 into 3 should be 21. So just check. Just check. The result will be here. That is, the result will be here. So this A register and Q register. I mean, look at this one. What are these two registers? These are the two registers. I mean, these are the two registers, A and Q, and this A and Q registers will be storing the original resistance. What is the value we are having? 0001, 0101. So this is the result. So let me check this one. What about the value of this portion? This is 1, this is 2, this is 4, and this is 8, and this is 16. And similarly, 32, 64, 120 will be there. So add these values 6.